Hi everybody, it's Friday the 26th of February and this is your last maths lesson for the week. You'll just need your paper and pencils today because you might want to draw some fraction bars, you might want to draw some number lines, and again you might want to write down your times tables to help you. We're looking at today subtracting fractions, but this time looking at breaking the whole, which will be explained to you later. To begin with, here is your 4 a day, so pause the video, have a go at your chosen colours, and then your answers will come after. Here are your answers for your 4 a day. Pause the video and check if you made any mistakes. Can you work out where those mistakes are? And then we'll move on to our get ready questions. Our get ready questions are coming up. Again, when they see them, pause the video, have a go, and then the answers will come afterwards. Pause the video and have a go at these get ready questions. Let's have a look at our answers. Question number 1. 1 whole is equal to 5/5. Question number 2. 4 wholes is equal to something thirds. Well, if it's thirds, then it's our 3 times table, and then we can multiply 3 by 4, so it would be 12 thirds. Question number 3, 6.5 take away 5/12. Now to do that, we can see that the denominators are not the same, so we'd have changed our 6.5 to 6 6/12. Because 6/12 is equivalent to a half. Then we could have subtracted our 5/12 from our 6/12, leaving us with 6 1/12. And then for the last question, we had 2 wholes take away a third, and that would have left us with 1 whole and 2 thirds. Well done if you managed to do those. Now we're going to get ready with our learning. Here we have a question, and it says 2 1/4 take away 5/12. And Tiny the Turtle says, I don't think it's possible to calculate 2 1/4 take away 5/12. I'm going to give you 10 seconds. Do you agree with Tiny or not? Or is there a way that you can do it? 10 seconds to have a think. Let's have a look and see. What could we have done first? Well, we could see that our denominators are not the same. So the first thing we should have thought about is how can we make them the same? And we can change our quarter into 12ths by multiplying by 3. So instead of 2 1/4, we can look at it as 2 3/12. Now, can we do 2 wholes and 3/12 take away 5/12? Have a think. How could you work that out? Now, the reason our lesson is called Breaking the Whole is because of this type of question. On Wednesday, we might have looked at the question like this: 2 wholes and 5/12 take away 3/12. And really all we would have had to have done was 5/12 take away 3/12, and the whole number would have stayed the same. But in the calculations we're doing today, we can see that 5/12 is larger than 3/12. So when we take away, we're going to break that whole. That means we're going to have to do something with this whole number and think about what to do with that. So pause the video, have a go. What do you think 2 3/12 take away 5/12 is? Let's have a look and see this answer. So we've got 2 wholes and 3/12, which we can see here with our fraction bars, and each of these bars is worth 1/12 and 12 12s along here. So we have 1 whole, 2 wholes and 3/12. And we have to take away 5/12 from there. So we could look at our 3/12 here, and that leaves us with our 2 wholes. Then we take another 2 away, and we've taken away our 5/12. So how we could have done that with our fraction bars to help us, we could have split our 5/12 into 3/12, taken away the 3/12 first, and then the remaining 2/12 after. And what would that have left us with? We can see there we did 2 wholes and 2 twelfths, take away 3 twelfths equals 2. Then we did 2, take away 2 twelfths is 1 whole and 10 twelfths. Now for some people what they like to do is turn those 2 wholes into an improper fraction and do 24 twelfths, which is the same as 2 wholes, 12 twelfths and 12 twelfths, take away 2 twelfths, which equals 22 twelfths, and then they change their 22 twelfths back to a mixed number. So there are 2 ways you might want to choose to do it today, but throughout we're just focusing on looking at our wholes and changing our wholes by breaking those up. So let's look at what comes next. We could look at it a different way by looking at it on the number line. We know here we have our 2 wholes and 3 twelfths because we have our whole numbers here, and we've got 12 markers on the number line, each one representing a 12th. So 2 wholes and 3 twelfths are here. We could then find 5 twelfths on our number line this way, and then we could work out the difference. So we could work out how much is it from 5 twelfths to the next whole number, and that would be 7 twelfths to get to a whole. We could then add 1 whole to get to 2, and then from 2 whole to 3 twelfths would be 3 twelfths more. Then we're looking at adding them together. 7 twelfths add 3 twelfths add 1 whole is 1 whole and 10 twelfths. So there you can see there are 2 ways to try and do it. We can as well look at writing our answer as an equivalent fraction, so we can divide 10 twelfths by 2 to 1 whole and 5 sixths. So have a think, either using the fraction bars or using the number line method, or if you think you can use your knowledge of your times tables to help you, how would you answer these 2 questions? Pause the video and have a go. Let's have a look and see. So question number 1 says 1 whole and 1/5 take away 7 tenths. So the first thing we would do is change our fifths to 2 tenths so we have the same denominator, and then we are doing 1 whole and 2 tenths take away 7 tenths. Let's look at it how we would do this one if we were using a fraction bar. So we have to take away 7 tenths, which we can split to help us on our fraction bar into the 2 tenths and then take away 5 tenths. So we've taken away our 2 tenths, then we've taken away 5 tenths, and that has left us with 5 tenths. And what is 5 tenths equivalent to? It is the same as a half. Now with the second question, we had 2 wholes and 2 ninths subtract 2/3. And again, we could have multiplied by 3 our 2/3 to change them to ninths, so we have 6 ninths now. Using the number line method, here is where 2 wholes and 2 ninths are. Here is where 6 ninths are, and it would be 3 ninths to get to 1 whole. A 1 whole jump to the next whole number, and then from 2 wholes to 2 wholes and 2 ninths is another 2 ninths, and we could have added those together to give us 1 whole and 5 ninths. Either way, it doesn't matter how you got to your answer, if you used fraction bars or you used a number line or you used your times tables to help you, then that's okay, as long as you got to that right answer and you found a method that you feel happy using. So let's have a look at this one here now. We've got A and we've got B. And pause the video and have a think. Which calculation will break the whole? How do you know? Have a think. Pause the video. Have a look at those 2 questions just by looking at them. Which ones will break the whole? Will you have to go into your whole number? Let's have a look and see. We can see that 2 wholes and 2/14 is what we would change our 2 wholes and 1/7. So now we're looking at 2 wholes and 2/14 take away 6/14. And we can see that our calculation that we are subtracting, the numerator is larger than the numerator in our first part of our question. And that's our clue, how we know, because the numerator is larger than the subtraction with our mixed number. And when we were to change 2 wholes and 6 sevenths, to take away 1/14, we can turn 6 sevenths into 2 wholes and 12/14, but we can see here in our mixed number the numerator is larger than what we have to take away, so that would not break the whole. So A is the calculation that will break the whole. Coming up now are some questions for you to try. Pause the video, have a go, write things down to help you. Use a method that you feel happy with, and then your answers will come after. First one, it says complete the subtractions. Use the bar models to help you. So the first question is 2.5 take away 7/12. So what would you change? We don't have the same denominator, so have a think. What would be your first step? What would you do first? Use your fraction bars if you want to help you, if you feel happy doing that, or you have your own method. So pause the video, have a go at these three. Let's see. You can see with the pictures how we could have done it. 2.5 we could have changed to 2 wholes and 6/12, and then subtracted 7/12 from our 2 wholes and 6/12, and that would have left us with 1 whole and 11/12. Question 2, we could have changed 2 1/3 over to 2 4/12 and taken away 7/12, and that would have been 1 whole and 9/12, or another way of saying that as an equivalent is 1 whole and 3/4. And then for the last question, we had 2 whole and 1/4, which we could have changed because our denominator we needed to change to 12ths, to 2 wholes and 3/12, take away 7/12 is 1 whole and 8/12, or 1 whole and 2/3. Well done if you managed to do those ones. Have a go at this question here now. So there is A, B and C. Part A, complete the subtractions. That's the first thing you need to do. Then part B, it asks you at what point did the answer break the whole. So if you notice, you're looking at the same number, 3 1/4. You're taking away 1/8, 2/8, 3/8, 4/8. Which calculation did you have to do that involved breaking the whole? And why did that happen? So you need to identify what point did the answer break the whole, why did it happen? And then question C, tick the calculations that will break the whole. Looking at these, which ones would you have to break, and just write them down. Pause the video and have a go at those 3 questions. Here are your answers. So for the first one, our answer was 3 1/8. Then we had 3 wholes, 2 wholes and 7/8, 2 wholes and 3/4, or 6/8. And the part B, it says at what point did the answer break the whole and why? Well, it would have been this question here, the third one, 3 1/4 or 3 2/8, take away 3/8. And it asked you why. And we looked at that before about how in our mixed number, the numerator in the mixed number is less than what the numerator is in what we're taking away. So that was your clue as to how do you know which one it is and why is it going to break the whole. And then the last question, it says tick the calculations that will break the whole. We should have again tried to convert our numbers so we have the same denominator. And again, if the mixed number numerator is less than what the numerator is we are taking away, that would have been our clue. So it would have been 3 1/2 take away 9/10 and 4 2/5 take away 7/15. Well done if you managed to do that. Same again, have a go at these 6 questions. Complete the subtractions. Again, before you go, have a look, what will you have to change if the denominators are not the same, what will you change them to? and then have a go at breaking the whole. Here we are. Here are our questions, and here is in orange what we should have changed our fractions to so we have the same denominator. Have a look and see how you did. Well done if you managed to get them. And let's look at the next part. Let's look at this one together now. And this one says, Dexter watches television for 3 2/5 hours during a weekend. Dora watches 13/15 fewer hours than Dexter. Dora watches 1 hour of television on Saturday. For how long does Dora watch television on Sunday? So looking at that information, what would be the important parts here we would need to know? We'd need to know that Dexter watches 3 2/5 of an hour. We know that Dora watches 13/15 fewer. We can see that our denominators in the two questions are not the same. So we're going to have to do something about those to help us work out that answer. So let's have a look using the bar model. So Dexter watches 3 2/5 of an hour, and that's his bar there. We know Dora watches less than Dexter, and we know that it is 13/15 fewer hours than Dexter. Have a think now. How can we work that out? How long does Dora watch television on Sunday? Let's have a look and carry on this problem. So we've got to do our calculation. First of all, to find out, we've got to do 3 2/5, subtract 13/15. By doing that, that will tell us how much time Dora watches here. So to do that, we would need to change our denominators to 15 by times in by 3. So now we're going to do 3 6/15, take away 13/15. Have a go and see what that would be like. We could take away the 6/15 to take it to 3 wholes, then do 3 wholes, take away 7/15. And 3 wholes take away 7/15 is 2 8/15. And that would tell us that Dora watches 2 wholes and 8/15. Dora watches 1 hour of television on Saturday. For how long does Dora watch television on Sunday? So if we watches 1 hour, what will she watch on Sunday? We would have to do 2 8/15, take away 1, which is 1 hour and 8/15. That's how long she watches television on Sunday. Let's have a look at this problem. The difference between a fraction and a mixed number is 3/4. The fraction has a denominator of 12. What could the fraction and the mixed number be? So here is our calculation of what it should look like. So we should have a whole number and a fraction, take away 3/4 equals another fraction here. What information do we already know? We already know that the fraction has a denominator of 12. So our answer must be 12ths. So now we could change it and look at our answer like this. 1 whole and something 12ths, take away 9/12 equals something 12ths. So it could be 1 whole and 5/12. Take away 9/12 is 8/12. That's a possibility. So looking at that type of problem, we're going to have a go at some different questions now. Again, you need to pause the video and have a go. With this one, there's quite a lot of information here, and it says here are some ingredients. So you have a bag of potatoes, some cheese and some carrots, each weighing different amounts. First question, it says how much more do the carrots weigh than the cheese? So we've got the carrots weigh 1 2/5 of a kilogram. The cheese weighs 7/10 of a kilogram. How much more? And that's a subtraction language. So that's our first question. Question B, it says Jack uses 17/20 kilograms of carrots. How many kilograms of carrots does he have left? And C, Jack uses all the cheese and the same amount of potatoes. How much do the leftover potatoes weigh? Pause the video, have a go at these questions. Let's have a look. For the first one, how much more do the carrots weigh than the cheese? Well, the carrots weighed 1 2/5, which is the same as 1 4/10. And then we should have taken away 7/10, and that would have left us with the carrots weighing 7/10 more than the cheese. Question B, it says Jack uses 17/20 kilograms of carrots. How many kilograms of carrots does he have left? So we should have converted 1 2/5 to 1 8/20 and subtracted 17/20 from there, and that would have left us with 11/20 of carrots left. And question C, Jack uses all the cheese and the same amount of potatoes. How much do the leftover potatoes weigh? And we should have done 2 1/2, take away 7/10, or 2 5/10, take away 7/10 is 1 whole and 1/10, or 1 whole and 4/5 of a kilogram. Well done if you managed to do those. There were some tricky ones there, but very, very well done if you had a go. Here's another problem to try. Eva is doing the long jump. On her first attempt, she jumps 3 2/9 meters. Her second attempt is 2/3 meters shorter than her first. How far does Eva jump on her second attempt? So again, looking at the information, what can you find? We know that her first jump is 3 2/9 meters. Her second jump was 2/3 of a meter shorter. So what does that word tell you? Shorter. What language does that tell you need to do? And again, our denominators are not the same. So what else do you think you need to do in order to calculate this question? Pause the video and have a go. Here is our answer. So what we should have done, we had 3 holes and 2/9, take away 2/3. We could have converted our 2/3 to 6/9 by timesing it by 3. 3 holes and 2/9, take away 6/9 would have given us 2 holes and 5/9. Here is our final challenge for today's lesson. Again, it's different to an odd one out. This is correct or not correct. So you have here 4 different calculations with an answer. You need to work out, is the answer correct? So for example, 5/6 add 2/3 equals 7/9. Is that correct or not? If it is correct, move on to the next one. If it's not correct, can you explain why is it not correct? What mistake has been made in order that is incorrect? Pause the video and have a go at these by yourself to see if you can come up with the answers. And that's the end of our lesson and the last one for the week. Well done everybody. And again, if over the weekend or today you want to carry on practicing your skills of fractions, important this week, we've been doing lots of subtracting, so you can go on to your subtracting fractions. If you want to simplify it for yourself and make it a bit easier, you can do your adding fractions with the same denominator. If you still want to practice your converting and improper fractions, you can do that as well, and finding equivalents. But well done for this week. Miss Howe will be out of class. I will be in class next week, and enjoy your weekend and speak to you soon. Take care. Bye bye.